Everyone, in this video we're going to look at z-scores, otherwise known as standardized scores or standard scores. So it does relate to the normal distribution, but instead of just having your mean and your standard deviation as a specific value, we make the mean 0 and the standard deviation is 1. So if we just go back to the normal distribution, so I might just look at this diagram here, which we looked at in the previous video. You can see we've got the mean in the middle, and then we're 1 standard deviation above, 2 standard deviations above, 3 standard deviations above. So if we thought of this as a number line and made the mean 0, this would be a z-score of 1, this would be 2, and this would be 3. And then going in the other direction, we've got -1, -2, -3. So that's basically what your z-scores are. So instead of having values here like we did when we calculated the questions with a normal distribution, so let me just show you quickly an example. All right, so this was a question we did in the previous video. So instead of having these values down here, all right, you would have a z-score. So it'd be 0, 1, 2, 3, and so forth. So if you had a standard score above 0, so if you were above 0, that means you are above the mean. Okay, so if you're above 0, you're above the mean. So the further away you are, the more above you are. And then below 0, you are below the mean. All right, so that would be a z-score of z is greater than 0, and this would be z is less than 0. Now to calculate the z-score, we just use this formula here. All right, so there it is in Word. So standardized value, which we use the symbol z, the actual value, which is x, minus your mean, which we call x bar, over your standard deviation, Sx. So you can use that formula to calculate your z-score, and you can rearrange it. So you can see what they've done here. If we wanted to calculate the actual value, we can just rearrange the same equation, and there it is in words, but there it is in symbols. So x equals your standard score times your standard deviation plus the mean. You can also just use solve in your calculator if you wanted to. So you could use this and then just use solve. All right, so this is pretty much what I just said before. So if your z-score is positive, your actual value is above the mean. If it's negative, it's below the mean. If it's 0, it's equal to the mean. If it's 1, it's 1 standard deviation above, -2, 2 standard deviations below. All right, so we kind of discussed this at the start of the video. Would be very useful to have in your bound reference. So here are the diagrams again with the 68, 95, 99.7% and just the z-scores. So there's your z. All right, so a little bit different to before, just slightly different. I just scroll back up. All right, remember we had the mean and then the mean plus the standard deviation. Here we've just got the z-scores written there. And then you've got your percentages as well, just like before. Okay, so very much the same as the normal distribution, we're just standardizing it. And the whole reason we standardize is to compare groups. So if you think of, how study scores are calculated, if we wanted to compare how you went in one subject with how you went in another, you might compare yourself to the average of the class. So let's have a look. I know there's a question that we're going to do. I think that's it for the theory. Beautiful. All right, so the first question we're going to do, let's just keep scrolling, here is we're going to compare some subjects. So we've got 5 subjects here. It still refers to general as further maths, which is quite funny. All right, the table below contains the scores a student obtained in a practice test for each of their VCE subjects. Also shown are the mean and standard deviation for each subject. So let's say these were your 5 subjects. This is the mark you received. All right, this is the mean for your class, and this is the standard deviation. All right, so we're going to use that information and plug it in to the standard score formula. Now, this should be in your bound reference, but I am pretty confident it is also on your formula sheet. So Z equals your value, your actual value, minus the mean over the standard deviation. Now, if we just have a look at these values without calculating anything just yet, if we just have a look at English. So for English, if we got an actual value of 69, we can already see it's above the mean. So we know that we're going to get a Z score that is above 0. If we have a look at chemistry, the mark and the mean are equal. All right, so that means you're going to get a Z score of 0. So your Z just tells you how you compare to the rest of the group. Then I'm just seeing if there was one where we didn't do as well. So psychology got 73, but the mean of the class was 82. That means you did below average in psychology. So even though we can see that psychology, the result was quite high, but in comparison to the rest of the class, it was low. And aeroplanes. Okay, hopefully there's no more loud aeroplanes. Chemistry, you can see that it is quite a low result, but it's average as the class. So you could say, well, yeah, it's okay. You're doing average. And then further maths, 55 again, but well above the mean for the class. So you could say did quite well in further maths, which is what general maths used to be called back in the day. All right, so if we're calculating the Z score for each subject, all right, so we'll do English first. Actually, I might write all the subjects because then we can just quickly do it in the calculator. Biology, chemistry. I'm sure some of you watching, these are your actual subjects, although we call further general maths now. And then psychology. All right, so remember this is your Z score formula, so I might just do it in a different color so we can easily see it. So for English, we do Z is equal to our actual value, which is 69, minus the mean, which is 60, over the standard deviation, which is 4. And we could just plug that straight into the calculator. All right, so 69 minus 60, just make sure if you're not using the fraction like I've just done, and if you do 69 minus 60 divided by 4, you're only going to divide that 60 by 4 and see how you get a completely different answer. Your Z score should be between -4 and 4. All right, probably wouldn't be greater than that because 3 standard deviations is 99.7%. So even getting 4 is unlikely. All right, so if you did do it this way, you just have to make sure brackets go around those two terms. Oh my gosh, now there's noisy birds. All right, so it's 2.25. And you can do that for all of them. So let's just quickly do that in our calculator. So I'm just going to use this fraction button. So for biology, we got 75 minus 60 over 5. So we get a Z score of 3. All right, so they sound like cockies. Oh, I don't know whether you can hear them. That's so loud. All right, the next one, let's do, we know it's going to be 0, but let's just see that it is 0. All right, so there we go, because the mean and the standard deviation are the same. All right, so further maths, we got 55 minus 44 over 10, so we get 1.1. And then psychology, -73 minus 82, we know it's going to be negative 2.25. All right, so there's the Z scores. So part B, use the standardized scores to rate the students' performance in each subject. assuming a normal distribution. Okay, so the higher your Z-score, the better they're going to have done because they're above average. So the highest one is biology. So we'll go bio, whoops. And then the next one is English, followed by further maths, then chemistry, and then psych. All right, so if we're using the Z-scores to rate them, then you can see that. And it's probably a good idea to use the Z-score to compare your subjects because obviously some subjects are harder than others. So let me just have a look here. So chemistry and further maths have a lower mean for the class. So comparing how you went with the average of the class is probably better than just saying, oh, I only got 55. All right, let's move on. The volume of soft drink in a small can is normally distributed with a mean of 300 mils and a standard deviation of 2 mils. So remember when we're reading questions, as soon as we see normal distribution, all right, and then we've got our mean and our standard deviation, I think it's always a good idea, just so we can see what it looks like, draw your normal distribution. So we're going to put 300 in the middle, and remember we go 3 either side. And I'm going to fill this all in, even though I don't even know what the question is asking. I just think visually it is good to see what is happening. And then 294. All right, if a can selected at random from this population has a standardized volume of 2, so Z equals 2, what percentage of cans in this population contain more soft drink than this can? So we want the percentage contain more than this can. All right, so I'm going to just write underneath those values the Z-scores. So remember, for your Z-scores, your mean is 0, and then we just go 1, 2, 3, -1, -2, -3. So they're our Z-scores. We want to do, what was it? Z equals 2. So there it is at 304. And we want the percentage that is greater. So we want this percentage here. So we can go back to our notes until we're extremely confident. Whoops, these aren't our notes. Until we're extremely confident with our percentages. All right, so here is 2 standard deviations above. So we're just going to add these up together. We can also see getting 2.5 from there. So we can add 2.35 and 0.15, or we can just write 2.5%. Approximately what percentage of cans contain between 302 and 306? So I might just get rid of what I had before. So this time we're looking at a percentage between 302 and 306. So here's 302 and here's 306. So we're looking for this part here. So I'm going from 1 to 3 standard deviations above. So going to my notes, I'll just get rid of that. All right, so we're going from, hold on, now I've forgotten what I was doing. Got distracted. We're going 1 to 3 standard deviations. I thought it was. All right, we're going from 1 to 3 standard deviations. So we're just adding up those 2 values. So you can see it's a little bit harder to do it from these diagrams because we're going from 1 standard deviation above to 3 standard deviations above. So we're just going to add these 2 numbers together. So 3.5 plus 2.35. And you can do that on your calculator, but what is that going to give us? 15.85%. That's my mouse. All right, so 15.85%. So with a normal distribution and the standard normal distribution, you just got to get used to using your percentages and also the standard formula. So just getting confident with using that. So the more questions you do, the better. You're going to scroll for me? There we go. All right, a set of scores has a mean of 100 and a standard deviation of 20. Calculate the actual score if the standardized score was. Okay, so we've got a mean of 100, a standard deviation, standardized score. So For this question, we're assuming it's a normal distribution. On an exam, it would actually say it was, because we can't standardize it unless it was a normal distribution. So here's our formula again. So Z equals your actual value minus your mean over the standard deviation. So all I need to do, I can use solve on my calculator, because remember we don't need to use solve. I thought we're solving for something else. We're solving for Z, so we don't have to do that. But just on our calculator, oh no, we do. Hold on. Yeah, we are doing the actual value. Sorry guys, I'm not reading the question correctly. All right, so we're calculating the actual value. So you can use solve. So I might just show you that way. All right, so solve, and Z for the first one is equal to 1. So we've got 1 equals, and then I can put my thing in. So X is what we're solving for, minus the mean. So it told us in the question that the mean is 100 over, not 30, 20, and then we're solving for X. All right, so X is equal to 120. So your actual score is 120. And if you think about that in terms of your normal distribution, there's 100, which is our mean. Our standard deviation is 20, so we're going up by 20 each time. So I might leave this on here because I think this will help us understand. And then our Z scores I'll do underneath in pink. So the mean is always 0, then 1, 2, 3, -1, -2, -3. So if we're looking at a standard score of 1, there we go, we can see it is equal to 120. So you can use that formula. When it's a whole number, you can just do your normal distribution. For the next one, we've got a standard score of 0.8. So 0.8 as a Z score is between 0 and 1. So when I do my calculations, I know it's going to be between 100 and 120. All right, so I can already think about what my answer is going to be. So if this was a multiple choice question on an exam, you can, do process of elimination. I know it's got to be between 100 and 120. All right, so we can do solve again. I might just highlight that and drag it down. So this time our Z score is 0.8. Nothing else changes because we're still using the mean of 100 and standard deviation of 20. There it is, 116. Remember I said it was going to be between 100 and 120. Then for C, we've got a Z score of 2.1. So 2.1 is kind of here. So I'm going to guess it's around 140 something. It's definitely between 140 and 160, but 2.1 is pretty close to 2. So I'm going to say it's 140 something. All right, so we can just drag this down again. The only thing that's changing is my Z score. So 2.1. All right, there it is, 142. All right, the next one should be easy. 0 means it's the mean, so I don't even have to calculate that. Whoops, not D equals D. So it's 100, and then E, we're at -1.4. So -1.4 is between -2 and -1. So it's going to be close to 70, I think, because it's kind of halfway between 60 and 80, but let's just calculate it on the calculator. So I'm going to highlight it, drag down. The only reason I can keep using the same formula and just changing the Z score is because for the question, your mean and your standard deviation are the same for each question. All right, 72, and then F, -2.5, so it's going to be between 40 and 60. So let's just plug that in. All right, and there it is at 50. Okay, so that's how you can find the actual value as well. So using solve, but remember going back to our theory, which I just realized we could have used this formula. Whoops. Oh, why isn't things working? There we go. We could have just used this formula here as well. All right, so instead of using solve, we could have just said x is equal to z. So for the first one, it was 1, your standard deviation was 20, and then we're adding the mean. So you can see we get 120 that way as well. That was for question A. All right, moving on to question 17. Just seeing how many questions there are. All right, we've got another one. All right, that's it. So 2 to go. I did quite a few questions for this one because it is probably a harder topic in normal distribution. So always pause at any time, have a go at doing the questions yourself, and then having a look at the solution. And remember, you can fast forward me or play me on 1.5 if I'm going too slow. All right, suppose that IQ scores are normally distributed. So remember, when we see that, we think of the bell-shaped curve with a mean of 100 and a standard deviation of 15. So let's quickly draw our bell-shaped curve. We have a mean of 100 and a standard deviation of 15. So we're going 1, 2, 3 above, 1, 2, 3 below. So we're going up by 115 each time. All right, and then on this side, we're going down 15 each time. All right, you can do that on your calculator as well. If you do it in your head and you make a mistake, so see how question A is asking what percentage of people have an IQ greater than 115. If you don't have 115 on here, it probably means you've made a mistake somewhere. So we don't do those sorts of calculations in general maths. You will if you do methods, but not in general. All right, so we're looking at 115, which is here. All right, so that's 1 standard deviation above. Hopefully you start knowing your percentages. It is 16%. So you can look at your notes. Hopefully you are looking at your notes, just not writing down what I'm putting there. All right, less than 70. So here's 70. Remember, here's your mean. So we're 2 standard deviations below. So that's 2.5%. So if you're wondering where I'm getting these percentages from, just keep referring to your notes. This computer's very laggy today. All right, so you can use your standard, or because it wasn't standard. Oops, where am I going? No, I don't want to do that one. Where am I? This one. Oh, that was the other one. Okay, so you're just using those percentages there. So 16%, 1 standard deviation above, 2.5 was 2 standard deviations below. All right, part B, to be allowed to join an elite club, a potential member must have an IQ in the top 2.5%. What IQ would be necessary to join this club? So the top 2.5 is 2 standard deviations above. So there, it's 130. So 130 or more. One student has a standard score of 2.2. What is their actual score? So this is where we can use, you can use solve like before, or we can just use x is equal to. Let me just get rid of that. Z times your mean. No, Z times your standard deviation plus your mean. So this formula I showed you before. So this one here. All right, so Z times the standard deviation plus your mean. It's the Z score formula, just rearranged. So we had a Z score of, I think it was 2.2. Your standard deviation is 15 and your mean is 100. So we'll just plug that into the calculator. I can find that. So 2.2 times 15 plus 100. So 133. And always just check whether that's right. So we know that that's 1 standard deviation above, 2 standard deviations yet. So we would expect it to be above 130. All right, moving on to question 18. The heights of women are normally distributed with a mean of 160 and a standard deviation of 8. So again, we're seeing that phrase, normal distribution. There's our mean, and here's our standard deviation. So let's quickly draw the bell-shaped curve. All right, so maybe pause and do it yourself, like instead of just watching the video. Make sure you're doing this at the same time. All right, that is not very symmetrical, but it's okay. It's only a sketch. We just want to see the numbers. We're going 1, 2, 3 above, 1, 2, 3 below. So we're going up by 8 each time. And then down by 8. What's it going to be? 44 and 136. Now, again, just making sure if it's not those numbers, then you may have made a mistake along the way. So you can use your calculator. It doesn't really take too long to do. I would actually, if it wasn't in an exam, I'd probably use my calculator just to be 100% confident. All right, what percentage of women would be taller than 152? So taller than 152, so we're here. And that is, if that's 0, we're 1, oops, let me do -1. -1 standard deviations below. So we're looking at this whole part here. All right, so we want taller than 152. So there's two ways you can do this. We know that this section is 16%. So to calculate the section we want, we can do 100 minus 16, which gives us 84%. Or, if you like, which is a bit longer, but you can still do it this way. Okay, so we can, oops, I was meant to get rid of that. There we go, get rid of all this. All right, so we're 1 standard deviation below. So you can add up all these percentages. All right, so 34 plus 34 plus 13.5 plus 2.3 plus 5 plus 1.5, and you should get 64%. All right, oh, sorry, 84%. Shorter than 176. All right, so let's get rid of that. So 176 is here. That is 2 standard deviations above, and we want shorter than that. So we want this part here. Now, if we're 2 standard deviations above, that means this section here is 2.5%. So we can use the same understanding as before, that the whole thing is 100. So we can take away that 2.5%. And we get 97.5%. Again, you can, where are we? You can add up everything from this diagram. All right, so we were 2 standard deviations, so you can add all these numbers together. You'd get the same thing. You can see it's just going to take a little bit longer. All right, what height would put a woman among the tallest 0.15 of the population? So I'm just going to get rid of all of this. All right, so we need to again understand our percentages. So you should have this in front of you. Above 1.5, here's 1.15, sorry, is 3 standard deviations. So we're now looking at 3 standard deviations above, 184 centimeters. All right, what height would put a woman among the shortest 2.5%? So 2.5 is going to be 2 standard deviations above, so it's 144. Again, using your percentages, they should be in front of you while you're doing these questions. One woman has a standardized height of -1.2. What is her actual height? So we know she's going to be somewhere between here and here, because that's where -1.2 falls. So she's going to be between 144 centimeters and 152. So let's calculate her actual height. So remember the formula, x is equal to z times sx plus the mean. All right, so the z score was -1.2. The standard deviation is 8, and the mean is 160. So we can just plug that into the calculator. Negative 1.2 times 8 plus 160. All right, 200. Whoa, all right. I'm like, no. This is probably why you need to always check your answer. That is not between 144 and 152. Okay, so what it's done is it's taken that answer from previously instead of, yeah. So I just can go back, check what error has been done. All right, there we go. That seems a little bit more realistic. So 150.4. So the actual value is 150.4 centimeters. All right, and I think that might be our last question before we head on to parallel box plots. All right, guys, bye.